Hello all, welcome to another LeetCode problem. So today we are going to solve a graph-based problem which is 797, all paths from source to target. So if I read the problem description, it's given a directed acyclic graph with nodes n from within n nodes labeled from 0 to n minus 1. Find all possible paths from 0 to n minus 1. So you have a graph given where n nodes are there and they are labeled from 0 to n minus 1. So let's say there are 4 nodes. So they are labeled from 0, 1, 2, 3. That is, and 3 is basically your n minus 1. And then from this particular graph, you need to figure it out all the paths that starts from your source node, that is your 0, and reaches to the end node, that is your target, that is n minus 1 node. So in this example, if you see that, so since it is a directed graph, so there is arrows, so you can traverse from 0 to 1 but not from 1 to 0. And then you can see here you can go from 0 to 1 and 1 to 3. So that is one path available here, and then you can also go from 0 to 2 and 2 to 3. So this is another path. So that we have to return, and the data structure is like that. You have a list of lists. So at 0th position you are given 1, 2. That means 0th node can reach to 1 and 2 nodes. That is, 0th node can reach to 1 and 2 nodes, and that first position can reach to 3. So first is going to 3, second position can reach to 3, and the last position, that 3 is cannot go anywhere. So there is no there is no path from 3. So that's why it is empty, right? So how do we solve this problem? So in order to solve this problem, I'm going to use a DQ. Well, I'll keep pushing. Well, when I start the DQ traversal, I'll start with the node 0, since we have to start with the node 0. And in this node 0, when I'm start, uh, I don't have any path, so only initial path only will be 1. So that is my first base condition. So this is I'm going to push into my DQ, right? So now I'll have a loop where now I have to do a batch process, and I keep traversing. So from 0th node, what are the paths available? So I can see that 1 and 2. So that's from the list. If I go and extract the 0th position, so I have 1 and 2 as a path available for 0th node, right? Now what we can do is I'll do a traversal, and then I'll just, from the DQ, I'm going to pop out the first element which is there, the element which is there in the DQ. So now if I pop out this one, so I'm going to get a 0 and then this one. So that's basically your node and then the path, current path. Now for the 0th node, I need to find what are the next node available. I can traverse from 0. So if I look at the list, so I have 1 and 2 as a possible node. So what I'm going to do is, since I can reach 1 and 2, so I'm going to append this path into the our existing path node, and then I'll push these nodes into the DQ. So since I can reach 1 and 2 from 0, so what I'm going to do is, in the DQ I'm going to push 1, and then I'll increment the existing path. So in this one path I'll add the another node which is 1, and then same thing for 2, that is 0 and 2. So now my DQ has 2 elements now. So this is going to be kind of a triple. I'm going to push into DQ. So now I have reached to 1, and then I also reached to 2. Now again I have to do a further, but I have not reached to my target node, because my target node is 3, because I'm looking for n minus 1, right, which is 3. So now again I'll explore the first node, because that is my that is into my DQ. So when I pop again DQ, so I'm gonna get 1 and 0, 1. So if I just go up a little bit, so now if I pop again, so I'm gonna get 1 and 0, 1, which is my path. Now if I further explore D1 based on the link, the data structure that we got, so 1 can go to the third node, right? So I'll again push a new element in the DQ with the third node, and the path will be 0 1, and I'll add 3. Same thing, I'll again pop 2. From this particular node I can reach to 3, and then I'll increment my path list, and add 3 here. Now both element, that is 1 and 2, has been popped up, so nothing left in this, but I added 2 more elements, right? That is 3 0 1 3, and then 3 and 0 2 3. So when again I pop up this element, I see that this is my target element, right? Target element equals to node. In this case, I'll add this path into my result set. Same way for this also, I'm going to add into my result set, because once I pop up here, I see this is my target element. So whatever paths so far I have traversed, that is going to be my result set, and at the end this result set is going to be my final result. So let's look at the code. So code, as I said, I need to find what is my target. So that is going to be length of graph minus 1. So in this, length of graph is 4 minus 1, that is the target node that I'm looking for. And then I'm starting from 0, so that's why I initialize the first node is 0. And then so far, since it's a base condition, so base condition I'll add 0 as in the path itself. If I don't add, then only I'll get is 1 and 3 and 2 or 3, but I have to start from 0, right? So I'll add 0. So, and then in this result I'll be returning the path that I have traversed. So once I start traversing DQ, so once I pop out this element, so 0 will be my node, and this is my path. Node is not equal to target, correct? Because still I'm at 0 position. Now I'll go and explore the graph. So for the 0th node, for this 0th node, what are the nodes I can reach? So in this case, I can reach in 1 and 2. So I'll add those 1 and 2 into the DQ. That is the node, that is 1, and then append path, that is your 0 plus 1. And then same case for this also. And then this while loop again continues, it will pop out the first element in 1, and then same goes for the 2. And then it will keep doing it. And after that, when it reaches to the target node, it will add into the result, and the result going to be returned to the function. So if I run this, so it works fine for the both test cases. You can go ahead and submit this. Alright, thank you. Thanks for watching this video. Hope you like it.